今日はちょっと日本語じゃなくて英語の方でいきますのでよろしくお願いします。Hi, so hi everyone. This is Inami, and I'm very happy to be back on this Try Swift meetup again. First of all, I would like to thank organizers and staffs for making this event happen. Today, I'd like to talk about some of the Swift concurrency lessons I learned in production. So this is me. I'm iOS engineer at GoodNotes. So GoodNotes is a company that the Yuta Saito, Katei-san, just introduced a while ago. And I also joined the same company. And if anyone still remembers, I was one of the first Try-Swift speaker in Tokyo in 2016, and also had a talk in 2017 in New York City. So it's been 6 years since then, and time just flies. So today's topic is about my experience in production. So let me also introduce about GoodNotes. GoodNotes is a note-taking and PDF markup app for iPad, iPhone, and also available on Mac. And as Katei-san just talked, we also support web, and including also Windows, which is run by SwiftWasm. This app has a long history and long-running product, and it's like 12 years old now. And last year, we got iPad App of the Year 2022, awarded by Apple. So the app has a very long history, and I recently joined the company, so I cannot tell you much about the old days. Possibly it was Objective-C. And what I can tell you now is that it's fully rewritten in Swift using RX Swift, Promise Kit, and recently Swift Concurrency. As a company-wide policy, we don't encourage to use Combine framework because we don't want to introduce yet another concurrency module to make code too much complicated. And yes, we are using SwiftWasm. By the way, it is important to mention that SwiftWasm doesn't like existing RX frameworks. Why is that? It's because RX Swift heavily relies on libdispatch, but SwiftWasm doesn't support it. Also, Combine framework lives in Apple's platform only, so it can't be used in cross-platform as well. So our only choice here is to use Swift Concurrency. And of course, Swift Concurrency is a newest concurrent API provided by the language, so we are encouraged to use it. In GoodNotes, we are using Swift Concurrency in web project first. And since last year, we expanded the use case to also apply in iOS, SwiftUI, and UIKit. But the things were not that easy as we first thought. We sometimes needed Swift Concurrency to incorporate with existing RX Swift and vice versa. So we will need those bridging APIs first. Then we also noticed that there are missing APIs which RX Swift has, but Swift Concurrency doesn't have it. So we need to fill in those gaps as well. Once we are ready preparing those initial setups, we can start gradual migration from RX to Swift Concurrency. And eventually, we can finish up the full migration at some point. In this talk, we will only focus 1 and 2. So first, bridging APIs. Let's take a look. If we remember RX Swift, we have single class for single async element and observable for multiple elements. And we want to convert that into Swift Concurrency's APIs and vice versa. Our question is, what types does these correspond to in Swift Concurrency? Well, single corresponds to async slows function, and observable corresponds to async slowing stream. Since we want conversion in both directions, we will need 4 APIs in total. Luckily, RX Swift already provides such bridging API for us. One is called single.value, which converts from single to try-await functions. So it's async function. The second one is observable.values, so that we can call for try-await. Then we also have as observable, which converts from async slowing stream to observable. So far, so good. But we are missing something. As I said, we need 4 APIs, but we still have only 3. Where is the last one? Well, actually, in Rx Swift, for some reason, it's missing. So we can create one on our own, like this code. So this has an extension, quite a long name, but it basically means extension single. And we can create a new initializer like this one. And inside it, we just call create, and we will use unstructured task inside, and just call the given function, async function f inside. And also, we want to do cleanup mechanism, which is to call task.cancel, right? So to do so in Rx Swift, we will use the disposable to wrap this task cancel so that cancellation mechanism goes from Swift Concurrency back into Rx Swift. So we prepared 4 APIs in total, and we are free to use whichever we want. If the project has more concurrency frameworks, such as Combine, PromiseKit, Rx, Reactive Swift, blah, 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 then all we need to do is just master them all and make all bridges, and success. Everyone likes learning everything, right? But of course, this needs a lot of learning effort. So we want to slowly remove Rx dependencies to only concentrate on Swift concurrencies in future. But can we free migrate to Swift concurrency right now? I would say not yet. Current Swift concurrency has quite a lot of limitations at the moment that cannot mimic the same elegant pattern as Rx Swift can do. Here, I listed up 4 basic components that are essential in Rx Swift. If we can apply the same idea in Swift concurrency, then our concurrency model will become even more powerful. So let's take a look. Suppose we have a Rx Swift code like this one. We observe search bars, text changes, do the debounce, flat map latest to pick up the only latest API call. Then we map to the results, and to the main thread. We will just bind to the table view so that table view just updates immediately. We write this kind of code in Rx Swift often, right? How can we do this in Swift concurrency? Well, we have some options. One famous one is called Swift async algorithms given by Apple that mimics the very nature of Rx frameworks. It has combine latest, merge, zip, chain, join, remove duplicates, debound, throttle, most of the things we want. And also they have async channel as well. And there are also third-party libraries as well, such as async extensions and asynchron. These are libraries complement some of the core features that Swift async algorithms doesn't even have yet, such as flat map latest, share multicast, and some of the subject classes. I will mention about this share API later, because this will be a very important API in this talk. So once we have these Rx operators ready in Swift concurrency, we can rewrite the previous code like this one. Almost looks the same as before. But here, we find the 2 syncing face emojis here. What does this mean? Actually, these APIs will require some sort of UI bridging mechanism. In UIKit, we normally use key value observation to convert the text changes into async sequence. And also, we want some UI table view binding mechanism as well. And trust me, just building these bridging APIs will become quite tedious. In Rx Swift, luckily, these tedious works are easily solved in Rx Cocoa module. And if we want to only use Swift concurrency to do the same thing in UIKit, we eventually need to reinvent the Rx Cocoa from scratch again. Do we want to do that? No. By the way, if we think about Swift UI, on the other hand, in many cases, we just want to use the .task modifier, and inside that, maybe we can just call for await to observe the changes. It's quite simple, right, in Swift UI. So let's summarize this. As we saw Swift async algorithms and third-party libraries, we can say that we have plenty of Rx Swift alternatives. Rx Swift one, but not for Rx Cocoa yet. Though this won't be a problem in Swift UI, since we just saw the Swift UI's example is simple enough, right? But it will be a big pain for UIKit projects. And you need to invent the Rx Cocoa from scratch again. We don't want to do that. So my 2 cents here is to stick with the Rx Cocoa and using bridge APIs so that we can cover both worlds. And just don't fall in love too much in Swift concurrency if you are a UI kit engineer. I would also suggest to use Swift concurrency from the internal code first, like this clean architecture diagram, and use the bridge APIs to incorporate with the surface layer. Surface layer can use any frameworks, whatever you want, and just bridge them. This approach will save your development time. So the first item is now checked. Now let's take a look at the second one, the dispose bag. Let's think about this simple MVVM pattern in UIKit. Normally, we observe state changes by calling for await inside the task, and view controller holds the task so that it can clean up on deallocation. If we forget this deallocation, the for await loop might keep running forever, which we might get in trouble some near future. To avoid this kind of problem, in Rx Swift, we normally use dispose bag instead, so that this dispose bag will take care of the dispose mechanism on the deallocation. And you can store many disposables together, so you don't have to write a lot of let properties inside the view controller. To mimic the same behavior as this in Swift concurrency, we can consider creating our own class like this one. Here I named cancel bag, which can append the cancellation handlers, as well as calling the cancel all on the daily initializer. Maybe it's a bit hard to see, but in the bottom it says init and we cancel all. This code omits the locking mechanism, so make sure if you want to write your own, always add the lock mechanism. And once we create this cancel bag class, we can also add extension task.storeIn, just like Combine's API, so that code will just look more familiar, like our Rx Swift code. So this technique is quite simple, but it's quite powerful. I recommend to use it. Now let's take a look at the test scheduler. Let's consider a class like this code. It's a view model that has a function called start, and it runs a while loop inside. And once the stop method is called, the flag turns on so that you get out of the while loop, and finally it's finished, becomes true. Please notice that inside the while loop, we are using task yield to await. This means the Swift concurrency runtime lets other tasks to run instead of just keep running in this loop. So it's not a busy loop, but more cooperative loop. And let's test this model, the view model. We call start first, then we call stop. What will happen? You might think, is finished becomes true at this point? Actually, no. What happens here is that because you are creating a task here, it delays the running, and eventually stop gets called first. What's more surprising is that it just goes out of the scope, so start doesn't even get called. This is the nature of Swift concurrency, and it's quite tricky part. The execution order is the tricky part. In Rx Swift test, if you remember back, we normally control this kind of order by using test scheduler instead. And we call advance to, so that before calling the stop, we advance the timer so that the view model's start actually runs. And then we call stop. But this stop doesn't mean it just finishes up the loop yet. So we might want to advance another timer so that finally we get the is finished flag to be safely get true. In Swift concurrency, we don't have test scheduler. So instead, we can actually use task yield instead. So as I said earlier, it's a method to let other tasks to run first before moving on to the next one. So that we call start with the unstructured task. This will be a bit slow, so we will wait for that first, and then we call stop. And then we also wait for another tick again to get the is finished to be true. But here comes another trouble. Unlike Rx Swift test scheduler, Swift Concurrency's task yield is not a precise deterministic virtual time advancing, which heavily relies on Swift Concurrency runtime. So if our start method is more complicated than previous example, just calling one task yield might not be enough. We might sometimes need 2 task yields, or 3 or more. We don't know how many times we need to loop this one. So this is quite annoying. Unfortunately, we don't have a good solution here, but we have a workaround. We can consider using this task mega yield provided by point free team. By default, this task mega yield will run 10 task yields in background threads sequentially. So it awaits quite a lot of tasks, but still it's quite fast enough. This is unfortunately not a beautiful solution, but I personally find it very practical to use it. Because in Swift Concurrency, it's not deterministic. Swift Concurrency is not deterministic, so we use this kind of hack to make more tests reliable. So to summarize, current Swift does not provide Rx Swift test scheduler equivalent type that works as a user customizable executor. This async uncertainty leads to indeterminacy, just like actor message passing, if you remember. This is indeterminate by nature. As a workaround, we can use task mega yields to have a more reliable testing. And you can also check out this Swift forum for more details. And lastly, there's an API called Swift Task Enqueue Global Hook provided by Swift runtime. This technique is used in Swift async algorithms test. And what this does is it hooks the runtime, actually. So you can replace with your own custom runtime so that it will become more easy to test. I have not tried this one, but this is something you might want to take a look if you are curious for more deterministic behavior. So test scheduler was quite a lot of pain, but I would say barely checked. And lastly, let's take a look into stream with current value. First, let's take a look at this Swift UI example. It's a view model, and with an observable object, and @published is used. And as I said earlier, using Swift concurrency inside Swift UI is quite easy. Just call .task and do whatever you want for await. And that's pretty much it. Okay, but wait a minute. It looks something wrong. Actually, our @published is in another castle called Combine Framework. So we don't, we cannot say we just migrated to Swift concurrency, easy. The game is not over yet. Since Combine cannot use in GoodNotes Swift version project, we have to consider this @published to become only useful for Swift concurrency. How can we do that? Actually, we should ask, can we do that? And the answer is yes. But one thing we have to keep in mind is that we have to be careful that async sequence is not multi-consumable by nature. What do I mean by multi-consumable? Let's take a look at this example. So we have Rx Swift's publish relay. We are subscribing with two observers, subscribers, and then we send value 1, 2, 3. And in Rx Swift, the value is shared and broadcasted so that each observer closure will receive 1, 2, 3 without any losses. This is a broadcasting shared mechanism. But Swift concurrency is a more primitive structure and is not designed in that way. Consider async stream, for example, stealing the continuation outside, and we do the same thing, 2 tasks, and we call for await each, and then send continuation yield. The result is that first for await will receive 1 and 3 only, but not 2. And the second for await will only receive 2. So this means this behavior is known as single consumable stream. And this is obviously not ideal for UI development, because in UI, we normally observe the same state multiple times so that each UI component can render depending on the same state. This often happens in UI. And we can remedy this kind of issue by turning the single consumable behavior into multi-consumable behavior using the share API. So I just call share. Now you can receive 123, 123 on both subscribers. I mean 408. Once we get this share idea in mind, we can consider a new async sequence that also has read-writable current value inside. Here I named shared current value sequence. I omitted the implementation, but basically what we want to do is, just have use share API inside, and it also is protected by the lock mechanism for the current value. By doing this kind of approach, we can create the same behavior as RX Swift's behavior relay. Then we can consider implementing its property wrapper. So inside, we are using that previous shared current value sequence, and we are creating its property wrapper. And the implementation is straightforward. I will talk about the projected value in a minute. So once we have this custom property wrapper ready, we can replace the combines @publisher into the new one. I named it async published. Instead of previous example was @published, and we eventually need to use .sync. This is combines API, right? But compared to that, we can now use 408, just like a Swift Concurrency's async sequence. So this is good behavior. I mean, this has a good API. But the next question is, what this $state is, the projected value. And the answer is, this is the read-only version of the shared async current value sequence. Here I named it async publish sequence. And basically, what this does is this is a read-write sequence with the current value, but we only expose the getter part. We don't use setter, so that this entire new class will be a read-only version. And this is actually the same as combines. There's an API called combines.publish.publisher. So we just went through 4 new types very quickly, so let's recap a bit. We first introduced shared async sequence to make it shareable so that it will be more multi-consumable. Then we also added a current value, the notion of current value inside the async sequence. I call it shared async value sequence. And this will be analogous to behavior relay. Third, we will create a property wrapper for that. And this will be analogous to @published. And lastly, we created a read-only version, just like combines publish.publisher, called async publish sequence. Now let's take this async published even more powerful and abstract. First, we create its protocol, like this one. So this is an async sequence that has current value, just like it's like a behavior relay, but it's only a getter. There's no setter, so that we can easily expose outside without any mutation happening outside. And we can also make this one protected by some lock mechanism so that it will be sendable. Here I also added a protocol called async non-slowing iterator protocol, which does not slow the next value. So this guarantees to have never slowing sequence. By using this abstract protocol, we can abstract the view model like this one. It's important to note that in general, using property wrapper has a downside that host class cannot expose its underlying storage. It can only mostly expose the wrapped value. But we want to expose this underlying value because it has more powerful structure. In this async published idea, I used the projected value instead, so that we expose this project value instead to make, this is a read-only version, so that it can be easily passed to outside world. For example, this is a use case of the view model protocol that has any async publish sequence inside. And we can call for await loop as well as extracting the current value like this one. So this viewModel.state sequence, we can do for await, and we can also extract the current value like this one. This behavior is very similar to behavior relay. The power of this protocol shines when we consider about its mapping and combining. So we can combine two async published. The sequence with the current value, we can combine together. And we can also map that. And this behavior has a limitation that we cannot call like compact map or flat map. Because compact map, you might lose the value, right? But this structure guarantees it has a current value or initial value. So it means it cannot lose that value, no? So by nature of the property, we cannot implement something like compact map. Similar thing also applies to flat map as well. I won't explain too much in detail, but I think flat map is also impossible. So we can implement the map and combine. Let's take a look at the combine. Combine's implementation is quite straightforward. So we just create a new struct like this one, and we just hold the two async published sequences. And inside the current value, we just pass the same first current value and second current value in tuples approach. And the implementation inside here, we also use combine latest for the async iterator. And this is an example of how we use combine and map stuff. Suppose we have two async published, state 1 and state 2, but these are private. And we only want to expose the combined version only to the outside. How do? We can call $state1 combine with the $state2, map with the final public state, and pass it to the outside like this. So this is why combined mapping it will be powerful. So we just introduced quite a lot of things more than combines published API. But you might wonder, published is very powerful because it can use with SwiftUI, right? It's not, just, publisher or any sequence stuff. It can render SwiftUI. Thus, the one we just introduced, async published, work in SwiftUI. And believe it or not, async published can actually work in SwiftUI as well. And how is that possible? Here, I created a sub-protocol, async observable object. And this will override the original function. Object will change. I used here open combines approach, using the mirror technique to find out all the async published properties. And we just do something magical here inside, so that it just works like just normal published. By doing so, we can finally implement the SwiftUI app using async observable object and @async published. We just added async name. Other than that, all the code just stays the same. And this is Swift concurrency friendly, no more combine. It just works for SwiftUI view rendering. So at last, this is what I just said. And it works for cross-platform as well. Ta-da. And this is the illustration of how @async published is used in GoodNotes. Here we have some class with the demo app attached, so that this is a SwiftUI demo app, so that it just automatically renders with easy prototyping. But after that, we want to use it for the production app. To do so, we abstract into its view model protocol and let that use it instead. So we can just choose whatever approach we want, like this one. So to summarize, we just introduced a lot of sequences, so I won't go through each of them again. And what I just want to say is that it just works for SwiftUI as well, only using Swift concurrency. And lastly, I would like to summarize the whole presentation. So to allow smooth migration from RX to Swift concurrency, we want to first think about bridging APIs, and we already have that. And then before doing that code refactoring, we might also need to think about behavior relays and other stuff. to do so, I also, of course, cancel back and something other than that. Yeah, and the async published topic is quite a lot of in depth. So I hope you just I hope you enjoyed this idea, and yeah, that's what I wanted to talk in this whole presentation. So that's actually it for my talk. Thank you very much for listening.